Hi everyone, welcome to my hangar. My name is Scott McDaniels, formerly of the engineering prototype shop at Van's Aircraft. The reason I decided to do this video is with all my years at Van's Aircraft, inspecting customers' airplanes, doing tech support, looking at airplanes at fly-ins, and more recently as an EAA technical counselor and an FAA designated airworthiness representative in these last few years. One of the things that I've discovered and noticed that is the most common issue as far as finish quality goes is the quality of dimple countersinking on aircraft skins. Now, let me say right from the beginning that I've never seen anything that would equate to something that would be a concern for safety of flight or anything along those lines. It's just a finish quality issue. And a lot of people are probably perfectly happy with the way their airplane turned out, with the results they got from their dimple countersinking. But I know that it's very common that people are striving to do the best job that they can with the tools and the skills that they have. The best way to do that is to have a way to evaluate the work that you're doing and make a judgment on whether you're satisfied with the quality of the work or not. A lot of the things that we do in sheet metal aircraft construction have some type of a benchmark standard or a test for evaluating whether we're doing the work properly. A good example is the rivet gauges that check for the shop head dimensions based on the rule of thumb guideline, or even using the mil spec dimensions and measuring rivet heads. That makes it pretty easy to make an instant determination whether you're meeting the requirements for the standards that we have for rivet installation. When it comes to dimple countersinking, there really isn't any standards. There has been some rule of thumb guidelines that get spread from one builder to another throughout the RV community and the home builder community in general. But I think I'm going to show you in a few minutes here that one of the common ones actually isn't a true test and doesn't give you the whole story. So stick with me and hopefully I'll be able to give you some useful info in determining whether your dimples are to the quality level that you would like. So what is dimpling, or more appropriately, dimple countersinking? Dimple countersinking is the process of using a tool, for the most part what we refer to as dimple dies. Here's a set of large size for a larger screw, and we change the shape of the sheet metal by reforming it by compressing it between the two dies, in contrast to machine countersinking, which is a machining process that actually removes material from the part that we're working with, or parts if it's a sandwich buildup of multiple layers. And we actually cut material away to make the recess for the flush head of a screw or a rivet to lay into. There's a couple of different factors that come into play when we're dimple countersinking that induce a variability in what the result is that we get. The first one being what the thickness of the material is. The thicker the material is that we're trying to dimple countersink, the more force that is required to get the properly shaped dimple. It's no different than if you're just putting a bend on a piece of metal. It's really easy to hand bend a thin piece of a particular material, but if it is really thick, it may require heavy machinery even to attain that bend. It's no different with forming the dimple in the material, because we are essentially causing a bend to happen circular in shape around a hole versus just a straight bend, but the same process, it's affected in the same way. The second thing that comes into play, having a major influence on what the result is how big the hole is that we're dimpling. Because the bigger the hole, in general, the bigger the dimple, because it's going to be for a fastener, whether it be a screw or a rivet, that has a larger size to the head. So that means the dimple is going to be deeper and larger in diameter. So we're reforming or stretching the metal to a much higher degree than we are with a small dimple that's required for just the 3/32 rivets. So those two things, coupled with potentially variability in technique as we move from one dimple location to another, comes into play. It's obvious to see that a process that works real easily for a small dimple in a thin piece of metal is not necessarily going to have the exact same result with a large dimple in a thicker piece of metal. And that's what we'll be showing here in a few minutes, what some of the variabilities are. But before we get into that, let's cover a little bit of terminology. There's two basic means of forming dimples in sheet metal. One is what I call compression dimpling, which involves using tools, of which there are a number of different ones that can be chosen, that squeeze the dimple dies together with a compressive force while the material is in between them. The second one is what I refer to as impact or dynamic dimpling, which is still squeezing the material between the dimple dies, but the force is generated in a different manner. And it generally is a higher force than you can attain with any of the compressive dimpling methods, unless you have some large complex machinery that is sometimes used in factories. So some examples of compressive dimpling tools. One of the most basic is just a hand rivet squeezer, like this. They come in different sizes and varieties and different size yokes, and we'll talk about that in a moment. The yoke size comes into play as far as dimple quality. Moving up is a pneumatic squeezer. that produces a squeezing force in the same way that the hand squeezer does, but it uses air pressure when you actuate the tool to squeeze the two dimple dies together. Then impact dimpling is generally done with a tool similar to this. This is a really old one that goes back to some of the first tools that Bob Avery of Avery Tools built in the late 80s, early 90s. And this method was used, I would say, almost exclusively for dimpling larger skins and other parts until maybe about 15 years ago or so, when some other methods were introduced, in particular the DRDT2 compressive dimpling tool that is pretty popular nowadays. So let's get into some more specifics regarding the dimpling process and some of the things that need to be considered to get a good result. One real important point to keep in mind is in choosing the proper dimple dies, I see a lot of questions a lot of times, people being unsure about which one to use. And that is probably as much the fault of industry as anything, because the way a lot of the tool makers sell their tools, they are selling dimple dies for rivets, talking about the hole diameter, but then when the dimple dies get up into sizes for flush screws, then they talk about the screw number, and it's no longer referring to the hole diameter. So you're going to have to do a little bit of learning to gain an understanding of what those different terms mean. Basically, for rivets, the dies generally always refer to the diameter of the rivet that they're intended for. On RV kits, that's 3/32 and 1/8. And then anything bigger than that, the dimple die set will be designated by what screw or fastener number it correlates to. A couple of other details that are really important is that you know what the hole diameter is that you're about to do a dimpling process on. And by that, I don't mean that you have the right dimple dies, but that the hole is of proper diameter and ready to be dimpled with those dies. You should never be using a dimple die that you have to force the male pilot portion of the die into the hole because it is an overly tight fit. That will just induce stretching of the material before you even start forming the dimple, which can cause cracking on the perimeter edge of the hole. Another thing that can cause cracking is the edge finish of the interior of the hole. A punched hole never has the same smoothness on the edge finish as a drilled or reamed hole will have. That doesn't mean that we can't dimple punched holes, but you should always be evaluating the condition. When you were doing the deburring process, if it was necessary, was there some really major burrs on the holes? It could be an indicator that when the skin was punched, that the die that was punching the holes was maybe starting to get a bit dull. Another factor can be its diameter is reduced because it has been sharpened so many times, and that can be a cause for having a hole that is a tight fit from the pilot on the dimple dies. If you're encountering that, it's best to just final drill those holes to verify that it really is at a number 40 for 3/32 or a number 30 for 1/8 inch rivets before you do any dimpling. Another good practice is verifying the holes using a rivet as a go, no-go gauge. I already mentioned some reasons for holes not being to final diameter because of the tooling that was being used, whether it was dull or old or whatever. But on RV kits, there is a mix, depending on what model you're building, of parts that are punched to final size holes and parts that were punched with undersize holes and intended to be final drilled. It's sometimes hard to tell which is which, and the construction manual doesn't go into great detail leading you into which parts need that process done. So it's good to just always be checking with a rivet if you're not sure. A hole that's properly sized for the rivet and ready to have a dimpling process done should easily accept the rivet, meaning it should slip into the hole easily. So you can use that as a go, no gauge. That's a real good way to evaluate the parts in your kit to determine which ones were punched undersize and needing final drilling and which ones are already final size. Also do some very careful evaluation as to burrs on the edges. I already mentioned that it can cause a higher propensity to cracks because of the stretching on the metal that is going to occur when the dimple gets formed. This issue gets amplified the bigger the dimple gets. So a dimple countersink for a 3/32 rivet, it's not stretching the metal nearly as much as a dimple countersink for a number 8 screw. That's a much bigger dimple, it's a much deeper dimple, and it stretches the material much more. So the level of deburring quality and the finish quality on the interior edge of the hole is much more important. It's for that reason that it's pretty much a standard in RV kits that any hole bigger than 1/8 for a 1/8 inch rivet is generally not punched to final size, and the builder is expected to final drill those holes so that it cleans up the edge surface to a better finish quality to reduce the likelihood of cracking. I've set up a sample here for us to take a look at a number of different number 8 screw dimples in a piece of 0.032 2024 T3 aluminum to see what some differences are of using different tools and the different results. This first dimple we're looking at was made with a hand rivet squeezer with a 3-inch yoke, the Tatco model that I showed earlier. And the first thing I want you to take a look at is the highlighted ring that's around the outside perimeter of the dimple. Well, actually on this one, it's only about 2/3 of the way around, but that corresponds to the outside diameter of the dimple die profile. That is what has been generally used as a guide for whether a dimple was formed properly or not, meaning the presence of a ring entirely around the circumference of the hole and the dimple. Let's look at this next one. This was done with a hand squeezer with a 1.5 inch yoke. And notice this one has a better defined ring around the entire circumference of the hole. And this one was done with a pneumatic squeezer with a 2 inch yoke. And this one was done with my C-frame tool. So these were all done with the exact same dimple dies. And at an initial look, these two probably look about the same. And this one, not too much different. And to a lot of people, this one maybe looks pretty good as well. But let's induce something else to allow us to look at it closely. I'm going to bring a light with a grid reflecting on the surface of the material. And can you see the distortion of the lines around the dimple? That's indicating that from the edge of the dimple outward, the material is not flat. So let's go over to the next one. And it definitely looks better than the first one, but you can still see distortion in the lines around the perimeter of the dimple. This one still has distortion as well. And let's go to the last one. And suddenly, there's virtually no distortion. So what that's indicating is that the skin is pretty much as flat as it was before the dimple was formed, right up to the point where it dives inside the dimple, which means the resulting finish of the skin in this area will be about as good as it could be, whether the dimple had been formed there or not. But we can see the distorted lines as soon as we go to the one that was even done with the pneumatic squeezer. By the way, that was done at the typically highest recommended air pressure of 100 psi for most tools like that. And then these two done with a hand squeezer get progressively worse as far as the distortion with this one in particular. And the fact that it doesn't even have a fully completed circular ring around it indicates that it's the worst of the four. Now, the primary reason for that occurring is when you start getting into larger yokes on either a hand squeezer or a pneumatic squeezer, and with this one being a 3-inch, the yoke is actually flexible enough that when you're putting enough compressive force on the dimple die to actually form a dimple, that the yoke flexes and spreads apart, and the two dies are no longer coincident with each other as far as their alignment. The one is tilted slightly relative to the other, and it won't fully compress on the side that's outside of the yoke. So this sample piece is basically an equivalent to what the edge of a fuel tank skin would be. These holes are of the same spacing. And it's also very similar to a lot of the inspection covers that I believe are also 032 and 025, depending on the airplane. Now let's take a look at some examples of some small size dimples. In this case, 3/32 dimples on a fuselage skin that is 0.032 thick. This is a forward top skin for the fuselage on a project that I'm working on that I purposely under dimpled a row of holes. This was being done with the C-frame and a plastic face dead blow hammer, and all I had to do to under dimple was just hit not quite as hard as I'm used to doing, and I got an entirely different result. So this is a 3/32 dimple for a 3/32 rivet in an 032 skin. And let's move in close and look at a few of these dimples and see if you can tell a difference. From here, somewhere right in this frame is the under dimpled holes. But at this angle, unless it's somebody with experience that can look at that reflection line that's present across the middle of the skin, you probably can't tell which ones they are. But we'll zoom in close over here and take a look at this first. So that is a dimple that's about as good as you're ever going to get. You can see the grid reflection around the dimples there. There's virtually no distortion right up to the edge of the dimple, unlike the ones that we were looking at on the other sample that was similar to screw holes for fuel tanks, etc. So let's go look at these. Those are the same. That one's different. And that one. And that one. Can you see the distortion line in the lines? So that is showing that there is a lack of flatness in the area right around the dimple. Trying to get my light so it doesn't modulate the camera there. I also did a few holes on the edge of the skin with my pneumatic squeezer just to have a comparison. And that is these in this area here. You can see there's a little bit of distortion. Not near as much as the ones that were under-dimpled with the C-frame. But these down here on the edge were done with the C-frame. And there is zero distortion. Now, it wouldn't be practical for every builder to make a printed grid to apply to a light and be analyzing their dimples that way, though you could if you wanted to. But there's a much easier way that you can use once you have an understanding of what to be looking for. Skins, when we're dimpling, are usually laying flat, and there's usually overhead lights. So you can see the reflection of one of my overhead lights right here, and see as I move the camera so the reflection moves, there's no change in the reflected image as I go over those well-formed dimples. But now let's shift over to this row in the middle. And watch what happens. You can see the reflection distort as it goes in and out of the depression on each dimple. Now this is correctable. All I'm going to do is get out my tool and re-hit this row of dimples, and they will be fully formed and they will look no different than these right here. So let's recap what we've been talking about up to this point. First off, underformed dimples are not a safety of flight issue or in any way going to have an effect on the longevity or strength of the airplane. Generally, what we've been looking at is dimples that are probably 90% formed. It's just the last little bit that gets you back to having a flat skin adjacent to each dimple. Now, the reason that's beneficial is because everybody wants their airplane to look nice when they're finished. But even having perfectly formed dimples does not mean you're going to have a perfectly flat skin in that location once it's riveted together. Riveting is a whole different technique that can also induce its own variables in making the skin no longer flat just because of the riveting technique that was used. So this does not guarantee that you're going to have perfect reflections on all of your skins if you use these guidelines when dimpling. But that's also why it's beneficial to get the best dimple that you can, so that when you do start riveting the skins on, when you get the inevitable slight depressions from the rivets being set, that you don't have some that are already there just from when you were prepping the skins to install them. So I hope you find this information valuable. If you do, feel free to share it and put a like on this video so maybe we can get it out to more people and we can spread it around through the RV community. Otherwise, thanks for checking out the video. Bye.